Hi, so for my 112 term project, I decided to make an inpatient management application with algorithmic patient-doctor matching. And this was motivated by noting that a lot of the inpatient management applications I looked at did not use algorithmic matching. Instead, they used manual matching, which I don't think is ideal, and so I thought this was both an interesting and an important problem to solve. So before I hop into a demonstration of my code, I'll give some background on how the algorithm works. So the first part of the algorithm relies on an n-ary tree of medical specialties and subspecialties. So for instance, internal medicine branches into neurology, branches into behavioral neurology, which branches into our terminal child or our diagnosis, which in this case is psychosis. So for instance, internal medicine can also branch into cardiology, nephrology, etc. Neurology can also branch into neurodevelopmental disorders and its own diagnoses, and of course behavioral neurology branches into far more diagnoses than just psychosis. But the key thing to note is that for each diagnosis there is only one path to it from the parent tree. And therefore, by having this path, we can match doctors based on their specialty or subspecialty being closer to the diagnosis of this path. So, for instance, neurology would be better than internal medicine. So let's demonstrate that. Let's say our patient is Jack Black. Let's say his diagnosis is psychosis. And the severity, which is based on the standard 5-level triage scale that's used in most Western countries, is 5 being least severe and 1 being most severe. So let's say Blackjack is pretty psychotic, and we'll match doctors to those conditions. And so as you can see, neurology comes up as listed higher than internal medicine. And only those with a specialty or subspecialty within this given path show up. But how do we break ties between patients of the same specialty? So for instance, Jim Thiel and Scott Hume both have neurology as a specialty. Well, the algorithm takes into account both the number of patients that a doctor is currently attending to and the overall rating of the doctor. The way that works is the more severe a patient is, the more heavily weighted the number of patients a doctor is attending to is. And of course that makes sense, because if you were of a higher severity, or like a 1 or a 2, then you would want a doctor who has fewer patients that can thus divert attention to you. So Jack Black here is pretty psychotic, but if we make him only very mildly psychotic at a 5, then we see that Scott Hume is now preferred over Jim Thiel because of his higher rating, despite his extra patients assigned. So let's add some notes, and then enter Jack Black as assigned to this doctor. Patient successfully entered. We get some feedback, and also of note is that there's a lot of error handling on these user fields here. So if I try to enter, say, severity of A, then I get an error. Okay, well, now that we entered Jack Black, if we press search, then it pulls up all admitted patients right now, and see there's Jack Black. But we can also search by term. So for instance, psychosis, search only Jack Black has psychosis. If we search severity 5, then he also comes up. If we search severity 2, then we get a different patient. But let's go back to Jack Black. So if we select Jack Black, then it'll print his notes, and now we can update or discharge him. So if we update him, we can change his parameters. So if we make his severity 3 now, and assign him from Scott Hume, which he was originally assigned to Jim Thiel. Let's do that. Update. Patient successfully updated. Let's go back to search, and we see that Jack Black was indeed assigned to Jim Thiel now, severity of 3. We can also change his diagnosis and view all diagnoses from this button. So let's say he no longer has psychosis, but he has, or he needs hand surgery. We'll see orthopedic surgery comes up, followed by general surgery, but it's not important. So, okay, let's say Jack Black has a miraculous recovery, and we discharge him. It'll ask, are you sure? We say yes. And do you want to add a rating or review? Okay. And so the patient can leave a rating or a review, which is entered by the administrator who's using this program. So let's say Jack Black gives it a 4 out of 5, and says it was quite enjoyable. Would recommend. Now we can save this, and we'll say review rating successfully added, and that saves the review and rating to the doctor object in the database that Jack Black was last assigned to, which was Scott Hume. And that's related to a feature that I didn't show earlier. So, for instance, let's say patient's John Lane. She has cardiac arrhythmia. Severity of 3. Match doctors, and we see cardiology shows up first, of course. And if we click View Review here, then it'll use a Markov chain to generate a brief string from the number of reviews that we have on John Wilkers. So for instance, if we read this, then it's care of my elderly mother, and I go to him myself. He's one of the best, his patients, and it shows I trust him. Okay, so that sounds good. If we go to Wilhelm Weissen, then it says he does not do his own peer-to-peer reviews with the insurance. Okay, so it seems that John Wilkers is more positive. There we go, he's a true professional. So the point of including this Markov chain was to give another holistic measure for the administrator to differentiate between tied doctors. But it seems that John Wilkers is in the lead, so we'll go ahead and enter him for Jane Lane. Yeah, that's about all. Thanks for watching.